welcome back, everybody. Let's get started. David is going to be presenting material movement. Can you explain just briefly what you're going to do, and then let's dig into why this is important, and then let's get to having some fun.
Yeah, so the use case that we're going to walk through today is something that many people have experienced in manufacturing. It's known as the material movement. It's that I have some material in some area of my production facility or in my just overall plant, and I need to get it from, in this case, the warehouse, and I need to move it out into a work center or a line or some type of line, and that's what we're looking at. So it's a very common thing, but how do we approach that through a UNS type architecture? And what are all the moving pieces and what all needs to happen there? So let me give you just a quick overview of what that is actually going to look like and what we'll get into. I have some rockstar animation that we'll take a look at here. But what we have is a warehouse management system. And even though this is traditionally a level 4 system, what we're asking it to do is dispatch and order. Some other system within our operation has requested some material be brought out to a particular line. So somewhere in a workflow, this is going to happen. Our warehouse management system is going to dispatch, and in this case, it's going to dispatch 3 different work schedules to some work centers that are located throughout the plant. So one of them is going to be a work center that is in our warehouse. One of them is going to be a work center that is in the packaging area. So this is the area that is requesting it. And then I also have another area that we have modeled as mobile equipment. And the work center that is in place here is not an actual physical work center. It's just being called an LGV agent, meaning the LGV agent is going to take work requests from, in this case, the warehouse management system. And it is going to see what LGV, this is a laser guided vehicle, that is available. And then it'll dispatch that LGV to go perform the work that has been asked by the warehouse management system. So all the LGV agent is doing in this case is just taking those requests, processing them, and then dispatching to the LGVs. So far, so good. And you're muted, Kevin, if you're talking. Yes.
Yep. So we are essentially taking data from the warehouse management system and then telling each of the areas what product needs to move, where, how, that kind of thing. And so we're going to be communicating that data through the UNS, and you're going to be getting into the details of the situation, and then a lot of the technical details, what the data needs to look like, the schema, some of the technologies, all the rest of that kind of stuff. Is that fair?
Yes. Yeah, exactly. Awesome. So, here's some rockstar animation for you. So the LGV is going to move over here. It's going to be assigned a storage tote. The work is now going to begin where I start taking the material that is in the storage unit and moving it into the storage tote. And of course, I need to move this thing back so you can actually see that material. And now all 3 of these things are going to move over to the packaging area, in which case I'll perform more work where I'm going to unload that material to a storage unit that is sitting out on the line. And that's it. That's all we're doing in this demo. But this is going to demonstrate all the moving parts for that actual transaction of just something very basic. So there's a lot that's going on here, and we're going to walk through it step by step of how we would do something like this using a UNS approach, where there's going to be a pub sub type architecture where my warehouse management system is going to send the work requests out to our equipment, and then these different work centers and the work units, or the storage zones and storage units are going to do all their thing. So that's pretty much what's it.
First of all, love the animations. Keep your day job. Don't call Disney. I think they're busy.
Right.
And then can you kind of just go through those steps again? Just how many steps were there so that we can kind of track that as we're going through the rest of the details?
Yeah, and as we get into, so I have another system that I'm going to walk through the exact, well, what does this workflow look like? And in each of those workflows, it will demonstrate what the payload is. But what we're really trying to do is decouple the communication between these systems, because historically this would be a point-to-point integration, and any other system that's interested in that information may not be able to understand what's happening. So the idea is that when we decouple, we use a pub/sub technology that I can present a payload into a system, it can consume the payload and then perform work. That's ultimately what we're trying to do. So we'll get into that. And I think really the question people get asked a lot is, well, why are we doing this? Why do we not want to do something else? And that really comes back to the idea that we are creating nodes in an ecosystem that all the other systems can consume that information. And the reason why I'm approaching it the way I am, so we'll get into some MQTT. We'll be doing some what's called BatchML. It's a standard for that particular payload that we want to utilize. And the reason why if we're doing that is because, you know, as I say, the best part of a UNS is there's no standard. The worst part of a UNS is there's no standard. So we're trying to put some standardization around what it is we're trying to do. Make sense?
Yes, standards. Love standards. That's something that I think is missing in a lot of the companies that we talk with. And that's what we're really bringing to. Awesome. Let's do it.
Cool. All right, cool. Let's get right into it. So let me make sure that my screens are all ready to go before I start showing my screen. All righty, so I made sure that I had a big green mouse because there's a lot going on this particular screen, and I wanted people to be able to follow along. So you had asked earlier about what the workflow and what does it look like. So just going back to the animation that I've already demonstrated, we have a system that's going to schedule some work. This is our warehouse management system, and I demonstrate that in green. And it's going to have it's going to process to the a work schedule that is going to be in mobile equipment. There's a work schedule that is part of my packaging area, and then there's also a work center, or it's going to process some information that is part of my my warehouse system itself. So the schedule work from a unified namespace perspective, these are the topics that activity is going to communicate to. So schedule work, there's a defined topic, there's a defined payload where that information will be sent. As we go through this demo, we have the LGV itself. Now, this is something that is going to be constantly communicating and updating its status. If we look real fast over what the type of information is in this particular LGV, you can see I have a battery percentage, I have a coordinate X and Y, I have a destination as where's this thing going? Is there a job order I'm working against? I want to know what the status is. Am I doing something? And then, of course, there's a storage unit ID. If you remember, there was that storage tote. We want to know what's actually on this particular LGV. One last topic that's sitting here is the update tag. This is not something that would normally be a part of a payload coming from an LGV or any type of system. This is purely here to do some business logic, and that's really why you're going to see it show up. But it's, again, so that when it receives a payload, this is a reference tag to the MQTT topic. It processes some business logic, and it updates that information. So that's what's happening on these white checkboxes or these white boxes. And then finally, where we actually do work, that's going to be done in our SCADA system. That's orange because, you know, we're using Ignition in this case. This would be information that would come from our from Ignition, and it would present that information out to the UNS, and it would do all of its topics and that type of thing. Something I want to make sure that I'm clear on is that don't think of all these buttons as a button that an operator is actually going to hit. All I'm doing is using these buttons to demonstrate this system has published a payload against a topic, and then how do the other systems respond to that information? How do they consume it? How do they process it? Those types of things. So, we good?
Couple things to review just to make sure that everybody's on the same page. On the right side, on your semantic hierarchy, enterprise site, area, work center, work cell, and you've broken it out. You have the mobile equipment, then you have packaging, then you have warehousing.
Correct. And warehouse is down here at the bottom.
Yep. Okay. So you've got it organized there. Warehouse on the bottom in the tag browser. I'm looking at the right side of the button diagram, if you will, just to make sure that everybody understands that that's the semantic hierarchy. And then on the left, the colors green, white, and orange. Can you go through those again just to make sure that everybody gets what each of those are?
Sure. So the schedule work, this is the warehouse management system. And what it is doing is that this is the payload that is coming from the warehouse management that is going to the various work centers that we talked about. So we have the LGV agent as a work center. We have just something generically called work center that's part of our packaging, and something that is generically called work center that is part of our warehouse. The white buttons are going to represent a payload coming from the LGV itself. So this will be LGV1 in this case, and it will just constantly be providing a status update. So these are events. The white are going to be more telemetry data, time series data, SCADA data, constantly updating. I've just given 3 updates because otherwise there were going to be a whole lot of update LGV status tags, and I didn't think that'd be meaningful. We'll begin and end an operation in the warehouse. The LGV will move again, and then we'll begin and end an operation out in packaging. And those operations are the actual physical movement of the material from the storage unit in the warehouse to that mobile storage unit, or that storage tote. It'll then move to the packaging area, and then it'll unload in the packaging itself, and that's the operation that goes along with that.
Okay, all right, I've got it now.
Okay, cool. And just since we're talking a little bit about the tag browser, I've also modeled the LGV. So these are going to be the asset models that are associated. So every LGV is going to have this type of information. You can see the LGV agent of the more work center type tags. And then even though I mentioned the update tag earlier, which was it's processing business logic, I'm also consuming process work performance and process work schedule. These are part of the ISA 95 parts 5 and 6 standard, and we'll get into that a little bit, but this is basically just doing the workflow itself. Come over here to the broker. You'll notice that right now there is nothing in the broker. Normally this would have all types of data in it with all the current status of everything that's happened, but we're starting with a clean sheet of paper so we can walk through exactly how is everything happening. So let's give it a go. So the first thing I'm going to do is we're actually going to schedule some work. This is my scheduling system that is now telling all these other systems there's demand. So if you look at the ISA 95 standard, there's something called definition. The next grouping of things is called demand. This means I'm scheduling work. Something needs to happen on some equipment. You can see that my LGV agent has a work order it's the job order 10,003. I have a schedule begin and a schedule end. So this is the request that's being made. This is when I've asked you to do this work. It gives you a beginning and an end time. The work center down here in the your production area also has another a work schedule with a work request, and it has job order 10,002 on it. You can see when it's beginning or when its begin and end times are, and then finally coming into the work center down here in the warehouse. There's also, you can see that there's that same work schedule, a work request, and then of course in this case, because we're in the work domain, we're going to be using job order 10,001. Again, there's a scheduled start and a scheduled end time. So that's all we've done at this point is just schedule the work. That payload has been presented, and let's take a look at what that looks like here in the broker itself. Because we're dealing with 2 different concepts here. So I look at my time series data or my telemetry data as, this is the traditional UNS structure that people are familiar with of the enterprise site area line cell or work center work unit. I've broken that up to where everything that exists in my level 2 SCADA system, all those models, you can see that those are broken out here, and you'll see what information just changed. And that, this is representing what's the current status. So I have a current, there's a job order, I have a scheduled quantity, units of material, that type of thing. Same thing in packaging and the like. And you'll see all this evolve. But this is what's all of it's done at this point is I'm now scheduling work out at those 3 areas. The payload itself is the transactional information. I do this a little bit differently. So per the parts 5 and 6 of the standard, what it takes a look at is, well, what is the system? What is presenting this particular information? And in this case, it is my warehouse management system. I also want to do version control. So my top levels are different here because this is a transaction between, it's geared toward one system. We want to ensure that all the other systems can gain access to it, but I put it at a top level so that anybody that's interested in anything that's happening in warehouse management system, I already have a top level domain. The versioning, what that allows you to do is that should I change a schema that I need to validate against, I have a different version that I can start publishing to, and then whatever consumers of that information are interested in that new version, they will then start going from warehouse management version 1 to version 2. You'll now see the familiar hierarchy scope, enterprise site will have the same areas and the line and cell. And within part 5 of the standard, when we start talking about what are the verbs that are associated with the action, there is pub. So there's a pub sub version of it. There is a push communication and there's a pull communication. Didn't want to get too far in the weeds, but in this case, because we're doing a push, we're going to use process, and what I don't have here is acknowledgement. So that's what that looks like. Presenting. So you'll see that all the work schedules are now getting presented with that process topic. And of course, there's a JSON structure. We'll look at this toward the end of the video, but that's all that's happened right now is we've communicated information from our warehouse management system, and then our level 2 system has consumed that information and assigned it what's the current state that's happening in all this equipment. So far, so good.
Awesome. Love it. Let's keep going.
Cool. All right, so now we're actually going to dispatch the LGV. The agent has said, LGV1, you're going to go take this work. Now you can see on my LGV1, I can see that I want to go to a storage unit. So here's my destination. I can see what job order I have. I can see that my status is active. And I've also been assigned a storage unit ID. So this is going to be now the LGV is going to go retrieve this storage unit ID, and it's going to load that particular material. So you'll notice that this status will change. So I have a battery and XY coordinate. You'll notice that as it moves, its coordinates change, its battery level drops a little bit, and this is going to continue to happen at some pace. You'll see all of this, this information change. Finally, I've arrived where I need to be. So you'll have battery XY, and you'll now see the status change to I've now arrived. So let's take a look at what that is over here in our broker. Because this was all time series and telemetry focused, you can now see I have an LGV topic, or you can see all that information is coming in. Again, update, ignore, it's business logic, but all of my updates of my battery, my destination, storage unit ID, all that same information is being presented so that if somebody's monitoring the LGVs within my factory, they know exactly what the status of that mobile equipment is. And that's what's happened. So that all makes sense?
Yes, it does. So you've started with scheduling the work, then you've dispatched, and then after dispatch, you've illustrated how the system does some updates as it moves, and then it arrives, and you've been updating the data in the namespace.
Yeah, in real time. So
in
now
real
we're
time.
going to be, yeah, in real time. And now we're going to begin the operation. So this is another transaction. We're going to start performing some work, and you're going to have a lot of stuff show up on this particular step. So the begin operation is going to be affecting my process work performance, because now I just had work scheduled. Well, now I'm actually doing that work. So it's counteract of what's the demand. Now, what is the result? What is the response that I'm getting of this equipment? So I'm going to process work performance. I'm also going to process material actual. This is the material movement, and these are two different topics that we're going to take a look at. Again, at the end of the video, what does this payload look like? But because I've begun an operation, you can now see that my LGV status has changed. But going out to my my work center in my warehouse, that I can also see that I now have a storage unit that is in use. I have a material ID that I'm going to be assigned to it. I have a quantity because I just started it. That's not been updated. I also have a storage unit where you'll see that this information is going to be updating when I'm done with the production, but coming down to the work center itself. Remember earlier I had the scheduled work, the scheduled begin and end time. I now have an actual begin time or an actual start time that has been populated within this. What this is allowing you to do is that I placed demand, I scheduled something, what was the plan, and now I know when did this operation actually begin. And a lot of your KPIs that you are going to use in many instances are going to utilize this same type of concept where I've placed demand, there is what's the schedule, and what did we actually do. So now we're going to load. This was that little red container that's moved over to that storage unit, and we're going to put it on the LGV, and we're going to start moving. So The way that I'm handling and transactioning the material movement in this case is that it is purely it's a transaction, it's one and done. Now, if you were going to do a continuous where you're constantly getting updates, you absolutely can do that. What you'll in effect do is create a bunch of these job responses of that material movement that's constantly happening. So maybe every 30 seconds or once a minute, that's how you would go about handling those. So there would be one work request. There might be multiple work responses or job responses coming out of that. So just something to keep in mind. So now I'm going to end that operation. Again, going to go to the process the work performance, process material actual. And you can see going here to the right that I now have my storage unit. I have 100.3 in there. My warehouse storage unit is now down to a lower quantity. And you can see that I actually ended this particular production. And now I get the actual time of what did I say I was going to end? How long should it take, and that type of thing. So now we've completed the first part of this. I have now taken the I've scheduled work. The LGV has been dispatched, moved over to the warehouse. It has picked up a tote, it's picked up the material, and now it is ready to depart and take it out to the work center. I'll pause real fast. Any questions, comments, something that wasn't clear maybe we need to talk about before we move on?
No, you've just reviewed what I was thinking about, which is in the diagram on the left side, scheduled work, dispatched, operation began to load, and now you're ready. The LGV is ready to depart at that point.
Yeah, and before I do that, let's just take a look at the broker. Now you can see that there's a lot more information that's shown up here. So before I just had work schedules. Now I have all those work performances with their related topic. These are all going to be BatchML topics. We'll look at those. But you can see my packaging area, that still just has a work schedule because I haven't done anything yet. I've just placed demand. And then I also have work performance here. You can also see exactly everything that happened in my UNS in real time. The last time this updated, what was I working on? What was the actual status? I have mobile storage. I have this tote. It tells me what's in it. Is this material available? Can I use it? What's the quantity, unit of measure? Equipment status is in use. The storage zone itself, you can see that my storage unit, we've modeled that. Now it only has 1800 left in it. You don't see the other information because that didn't change. Had this been a live production system, then some information would have been updating in real time around that. There's a lot more information would have been presented here. But because I didn't start subscribing until after there was already material in there, that's why you're not seeing it. But up here on the top, my warehouse management, these are transactions from my warehouse management system. On the bottom is the more traditional UNS of the current state, current status of what's actually happening in real time. So let's zip back and let's move the LGV now departs. So you can see my LGV is now active again. I'm going to start moving. I'm going to the packaging storage zone. That's the destination. We're going to update where it is. And now finally it's going to arrive. And you can see that I've now arrived, my proper location, battery, those types of things. So in fact, I've just done the exact same thing before. All I've done is that LGV has moved and now it's out in the packaging area and it's ready to unload its system. And that's where we're going to start performing some more work. So hitting this begin operation, you can see it's going to be now instead of my warehouse, I'm going to be in the packaging area and I'm going to do a process material actual. And I'm going to process work performance. So once again, you can see that I now have an actual start time for when I was going to unload it. And you also notice that when I clicked go, that the storage unit that is out there, it showed clean. Now it's showing in use. It's telling you what material is in there and how much is available of it right now and its unit of measure, that type of thing. So this is your real-time data. There's some business logic that's affecting all that. So now I'm taking that material that I picked up in the warehouse, I'm moving that over into the packaging area, and I'm unloading that in the storage unit that's now sitting out in my packaging. So we'll go ahead and we'll end that operation. You can see that I now have all the actual ends. You can see that that material, all of it was transferred. There was 103 in there. The mobile tote that I had, oh, now I got to find where I plop that. Oh, that's right. It's down in my mobile storage. So you can see that the tote looks like I have some math error in here. That should have been 0. So oops, somebody needs to fix that. but that would have shown 0. It's still showing that material is available. Something I do want to point out is my equipment status is still showing in use, and that's because the storage unit is now considered dirty. So if you were doing some kind of track and trace or genealogy, if you put a new material load in there, and we actually had a sublot or a lot ID that was associated with it, you would have to assume that whatever was in there the first time, that you're going to have some of that lot is also available or would be present, anything anywhere else. So what you want to do is, if you want to ensure that you don't have any material contamination, that now this particular storage tote, you want to go clean it somewhere and perform a cleaning operation on it. So just a couple of little ideas there. Jumping back over to the broker, you can see that now this is a fully, a full topic payload, where I can see that all my mobile storage unit and everywhere is now, everything is present. I have the storage unit, storage, all my material actuals with the payload, all my work performances are there. I have a storage zone, storage unit. I processed material actual and the like. On the traditional UNS or the time series, in that payload, you'll see that here's the current status of everything that is there. That complete process of when did I start work, when did I end work, what's all the information that I'm looking for, and I have the ability to know when did I schedule it, when did I end. And all the information that you're interested in is all here. What you're seeing and why that's moving is there's some logic that executes on the background when certain states change to something. It resets after a certain period of time, just so I can affect what's happening. But this is what it looks like, how we go about approaching the, how do we do transactional data, how do we do that time series telemetry data, that type of thing. So I'm going to go ahead, I'm going to update the LGV status. You'll now notice that this is all complete. It see where its location is, and it'll start now going through a reset process just to reset the demo over. It takes about 5 minutes to do, but that's the material movement. That's how all the business logic is handled. This is how all the topics are handled, and this is how all of what the payload looks like and that type of thing. So any questions before we get into the payload itself?
Kind of big questions, you might be getting into them. I'm simply sitting back and reflecting, holy cow, that was a lot of information. And it makes me think, how did you figure out all of these distinct steps that you go through here for this process? And I bring to mind a process that we all are using, which is an event storm. This feels like some of this stuff might have come out of an event storm, which is worth mentioning at some point here. And then I also think about, wow, there's a lot of data models. How did you figure out those? Is there a standard out there that helps you define what the data models are?
If only, if only. So in terms of the process step, I mean, this is just the business logic. And so you talk about event storming, and the idea is that we want to talk about what, as the name would suggest, or what are the events? What are the things that are of interest that happen in a manufacturing process or just any process in general? And it's a way to understand, okay, something happened. Well, what made that happen? And then what are the rules around making that thing happen? And then what are the decisions around when we go to make those things happen? And when it does, what's the data that gets moved around and that type of thing? So that's really what an event storm captures, is what are all these steps. So this was basically the workflow that was laid out by, and it's adapted a little bit. But this is largely it. If I've scheduled something, I need an LGV to move, I need to load it, and I need it to move, and I need to unload it. And then, of course, now that it's complete, I just need the ability to affect that. So that's largely what you're seeing here on the left, are just the steps of what that would look like. And this was, out of an event storm, they say, well, this is how it works, or this is what happens. And, the past tense in this event storm would be work scheduled is really what we're looking at. So that's where that came from.
So
in terms of,
before you go on, just as a point of reference, though, so the idea is, for context, the website is EventStorm or eventstorming.com, and the idea is a bunch of people get into a room, butcher paper, white paper laid out, bunch of post-it notes, and you just figure out what are all the events and data that and all the activities that happen in a process, whether it's material movement or a quality event, which we did recently, or a whole line. Let's understand what's going on. to really define the kind of activities and data that move for scheduling, work orders within the line. And so that this on the left of your diagram is pretty much the outcome of that process.
Exactly.
Okay.
Exactly. And so, there's an LGV that's going to move in that type of thing.
Yeah.
So yeah, this is all of the now it doesn't necessarily have to be an LGV, a laser guided vehicle. It could be a person that is doing all this,
Yes.
but
Exactly.
really nothing changes in the sense that instead of an LGV, Bob goes and does this type of work, and he's responsible for moving it, that type of thing. Could be a hand cart. I mean, it all applies. So to answer your question of how did I go about and establish what does this look like? Well, turns out there is a standard. I've already referenced it. So we're practitioners of the ISA 95 standard. Most people are familiar with the equipment hierarchy model. This is in part 1. This is where you get your enterprise site, area, work center, work units. You also have storage zone, storage unit. Those are equivalent. And then, of course, those names will change like line and cell depending on what type of manufacturing process you are, whether it's batch or continuous or or discrete. So those are really the main 3 that you're looking at. So those names will change a little bit, mostly because that's how they referred to in those types of industries prior to that happening. So that's going to be the standard that we use for this type of event-driven architecture, where we're going to have channels and we're going to have payloads. This is the same thing of topics in an MQTT broker. How the standard lays things out is very similar to what you looked at here in the in part 5, what we talked about. I'm going to have a core system, and there's a lot of latitude behind how you do that, and the standard will even give you some suggestions. How I approach it, just for consistency, is that I'm always going to have a system of record. So in this case, warehouse management system. I want a version, but now I'm going to get into what I generally reference as my hierarchy scope. I want to know where is this information being exchanged. That's exactly what we, the same concept that comes out of the unified namespace is where are we exchanging this information? And so because when I'm going from level 3 to level 2, where we want to communicate with higher level systems is going to be at a work center. And so now you'll see that the work center, I want to have a topic that is called work schedule. Well, when you look at parts 5 and 6 of the standard, there's all of the information objects have, there's a work schedule, there's a work request, there's a job order that's associated with that. So the way that the standard has you, or effectively has you perform that or execute that or build it and design it, is wherever you're transmitting the information, this is the hierarchy scope. Now you're going to want to use the noun. What is the information object from the standard that we are exchanging? And then what is the verb? What's the actual activity? Is this a push? In which case it is process and acknowledge. Is it a pull, meaning I want to do a show or a get and a show? Or is it a pub sub where I'm just pushing it out there and I'm not looking for any kind of acknowledgement, in which case it's a sync as a verb, and there's several variants of that. And that's how the standard goes about how you want to think about exchanging information throughout the process. So that's what's being used here. I recommend that people get parts 5 and 6 of the standard just to take a look at what we're done. Of course, this gives you a pretty good idea of what that looks like. So this is the channel of exchange of where we're going to do things. So system of record, the version, hierarchy scope, and then your noun and your verb. That's the format.
So it's the standards that define what these data models look like. And then you're going to start to get into actually showing some of those.
Correct. So right? Since you asked, it's a perfect segue into what we're actually going to do. And we're actually going to take a look at the payloads that were, when you take a look at all those JSON objects that on that MQTT broker, well, this is what they look like. So what I'm using here is that the ISA 95 standard is an interface between your level 4 and your level 3 systems. That's how it was envisioned. And what you're seeing here is the MESA or MESA. So that's your MES or Manufacturing Execution Systems Association. They have developed a schema based on the ISA 95 standard. This is their implementation of that standard. It's not the only one that exists out there, but it's probably the most common. When it was originally done, it used an XML type format, and it used XDS to do the validation. It's actually been converted to a JSON schema. So when I'm building these, I actually reference there is a publicly available schema that you can use to validate against. I'll pop up their website real fast. But the way that this works is that all of those models, so and it also has so the noun, which is the model, and the verb, they're all present here. So you notice I want to do a process batch. So I just bring up a search bar down here at the bottom, and I can now see what are all I want to process a batch production record. This is the it also, and I guess I should back up, B2MML is level 4 to level 3. BatchML is going to be your level 3 to your level 2 system. Your warehouse management system is communicating to your work centers. That's level 2. This is going to use a BatchML payload. What BatchML payload, where that came from, is that there's another technical report around how do we take ISA 95, ISA 88, which is a batch engine standard. How do we bring those two together? And what you see here is been realized by that BatchML. All I have to do is copy. This is the schema that I want to produce against. It will say, okay, here's your process batch production record. You drop it over into your tool of choice. I'm using VS Code here. And now I can actually start building out all of the requirements. When you're doing this, it'll tell you what's allowed and what's not allowed. That's the whole purpose of why we want to use a schema. The reason why we're doing this, and I think really getting to the meat of what we want to talk about, is if you use a standard schema, you can validate against it, but anytime you need to process a work schedule, regardless of where it is in your entire organization, you can use this exact same schema and it's going to follow the exact same pattern and have all the same types of information that's there. And that's really the power of it. So the way it works is that, go ahead.
A quick point on that to make, why is that important, especially for large organizations with multiple plants? Because that really becomes a challenge. And again, referencing work we're doing with some companies that are not small, and this standard really makes sense. Can you talk about that just a little bit, why this is important, this standards?
Sure. And this is one of the challenges and something we've run into in just taking a more bespoke approach, is that I may decide to do my information exchange differently than how you decide you want to do it. And when we bring those two systems together, we're going to have to abstract it yet again because the data and then the fields that you define don't match the ones that I have. So this just creates a common of when we're going to have this type of exchange where there's a work schedule, we're going to process that work schedule. That's the generic sense of what it is we're doing, and we're going to use a process batch production record model. So that's the first reason why we're doing it, is because it now creates data models that are consistent. It's data governance. I can apply this anywhere, and I'm going to be able to get the exact same result. So that's one of them. The next reason why we want to do this is that you're going to get into certain areas where I'm going to have, what they're known as arrays, where I can have multiple of these objects. So everything that's pink in a parenthesis, that's an object, or in a curly bracket, and anything that's in a square bracket, that means it's an array. There can be multiples in there. What this allows me to do is that I can scale and I can extend. So if there's additional information as I'm developing these JSONs that I need to now put more into that payload, not a problem. I have the ability to do that because there's more information that I can present here. There's a lot of flexibility. And I talk a lot about the thou shalt and the thou may. Well, that's exactly what this is that you are going to follow this standard, and there's going to be certain rules that are required that are associated with that, but I can now add more and more in here. So if I now have an equipment requirement that there's going to be more that's associated with this work, no problem, just drop in another equipment requirement object, and you can see what I have and how that's been built.
Awesome. That works really well.
Yeah,
that helps.
So following through, you'll now start to see things that are very familiar to you. If you've done any, this is going to be out of part 4 of the standard. This is going to be all some BatchML type concepts in my work objects. So I have a work schedule. I've given it an ID. That work schedule contains a work request. And the way that I approach this is that I give it a unique ID. Remember, this is the unique ID of this particular event that I'm looking at. So this is the ID of the transaction, if you will. And I like to give as much flexibility because these all need to be unique. And then I have a work schedule, I have a work request, and now I get into the job order. And the job order is going to be that, what are the actual things that are happening down here? This is going to do all the work. Within the job order, this is its work or the work evolution. So I talk about Pokemon of when it evolves into certain form. This is that work evolution. And within that, I'm going to have my equipment. I'm going to have my materials. And I'm going to have any physical assets, and I'm going to have personnel. But all you're going to see here is the equipment that I've assigned. Now, this is one big payload. This is not the individual payloads. I just have them here to demonstrate of how this information looks and how this JSON gets put together. Then I also have material requirements, and you'll see the same types of things. So I have material movement 1, and you'll see the material use is movement. There's also other values that you can have here. And this is, if you highlight over it, again, referencing that schema, you can see all the things that you can do. Point out real fast, most people are familiar with just the production of this. There's maintenance, there's quality, and there's inventory that I can do. And that's the information that we're going to have here. And what's that material use look like? So that's where we're going to have material use. It's a movement.
You had mentioned that all of this is in one payload, as if you might not want to have it in one payload. Can you speak to that a little bit?
Oh, yes. Yeah, so real fast.
Decide to or not to?
Yeah, no, I understand. So what I'm getting at here is that when you take a look at those 3 different payloads that I had, so one that went to the LGV agent, one that went to the works or the work center in the warehouse, and one that went to the work center in the packaging area. That's really what we're all seeing here. I listed them here just to demonstrate of I can have multiple equipment that's part of this equipment requirement, meaning I have the ability to scale and extend what it is that I'm doing. That's why it's here. I realize it's a little bit confusing. If you have questions about the specific payloads, certainly let me know and I can show you what all those look like. But this is here just to demonstrate a couple of or just demonstrate the concept.
Yeah, with this video, definitely like and subscribe and all that kind of fun stuff, but also throw in questions. Let's answer those questions. Let's get those questions out there so that people can learn this kind of stuff.
Yeah, absolutely. So that's the JSON payload. This was the request. This is from the warehouse management system that's going out to the other things. What's the equipment? What's the material? What's the who's the personnel? If there's an operator that's associated with it, and then finally, what is the what's the physical asset if it's associated with it? So that's where your resource objects come in. Same type of thing that I'm doing with my process, the work performance. So this is now going to be the response object of when I actually start doing this work. The schedule was the demand. I'm asking you to do something. It's the request. And performance is actually what happens. So plan versus actual. And you're going to see that this is very similar in the structure, other than this is work performance rather than work schedule. And I'm going to get into some different verbs. So I have work performance. I'm going to have a work response is the equivalent of that. And then, of course, I'm also going to have a job response that shows up down here, job response. A couple of extra fields in here. So because this is a performance, it's a response, it gives you the ability to say, well, what was the work schedule? What's the thing that asked me to perform this? And I have the ability to put that in here as well, so that if anybody other system is interested in this information, they can see, well, what was the work schedule that was associated with this work performance record or this object that I have? And you'll see that same type of thing. I have a work request ID. And then, of course, all the way down here at the bottom, I also have what was my job order ID. So I'm able to start marrying these things together. And you'll also see what was my equipment actual, what was my physical asset actual, and what was my material actual that was associated with that. All the same reasons why we're using JSON, utilizing a defined topic structure, is so that we can scale, we can extend, we can standardize all the things that we're looking for. But this is just the equivalent of it. Even though this JSON's fairly evolved, again, if you use a schema that references something, you can now build these out pretty fast. And the more you do it, the faster and better you get at it. So this was that response object coming back from here's what actually happened. And finally, the last one, this is going to be my process material movement. So in this case, I'm going to use a batch production record. I can say this was an event that happened. This is where it occurred. And just because we don't want to be, we want to ensure there's some verbosity in what it is we're doing. It's fairly involved, but you can see that there's an event. I had some material, and here's what the value of that material is. And you can see that there's a couple of values in here. Where you're going to potentially run into some trouble is that the standard just says this value can be key. That's the value. That the key of this key value pair is key. My the value of that itself can be anything. The reason why I have this in here as a quantity, because when my business logic is consuming this particular payload, all I'm going to be able to get at is the value, but the value of what? Am I writing this information to, am I consuming this as a quantity value, or is this a material definition value? This is where you are allowed to extend out and have as many keys as you want of what's the value of all the different types of information that's associated with this particular event. And you want to ensure that when you use key, these key names or the values, is that people understand what they are and you want to be consistent about it. So key of quantity, material definition ID, those types of things, you want to be as consistent all the way through and have that published so people know exactly what it is. So I just point this out is key. This would validate, but I could have any value in here as a string, and it may or may not be able to be processed. So you want to ensure that you're putting some data governance in here, enforcing it. It also gives the ability to, if I want to innovate, I can also put in my own keys that are relevant to me. It just becomes, if you're going to use this value, that's where it is. So I did want to point that out, but there's a lot of rules behind, the event type, event subtype, et cetera, et cetera. This is all part of the standard. Going all the way back to the very beginning of why are we doing it this way is because now we have an event-driven architecture, we have a defined channel or topic, and we have defined payload, so we can affect all those, all the information, the transactions. Because we've used a schema, we can do schema validation, we can do data validation, even on these keys to say, well, I have a key, so the schema validates, is the data that's in here, is that valid as well? And that's really the benefit of it. So it takes a little bit of work, but like learning a new language or really anything, once you get really good at doing these types of things, you can slog these out pretty quickly. And once you have enough of them, then it's almost becomes a copy paste, and you can do this very quickly. So that's really all I had for you. Any questions on what we've just gone through? I know this was quite a bit. We got really into the weeds, but yeah, this is what we got and how we do it. And it's a lot there, but once you've done this once, now your ability to scale it and also the ability to extend it becomes pretty good.
Awesome. That's a ton of stuff. Let's go back through it just as a quick review to make sure that I'm on the same page and everybody's on the same page. So if you go back to the early diagram, the first diagram, you've got the one where you had your really great animation.
Yeah, I would have to stop sharing. I can reshare if it help. I can do that.
Yes, please. I think that'll be fine.
Okay.
And then I have a real kick-ass question right at the end, at the very end.
All right, cool.
Question. Okay,
so I can reset all this stuff using that reset animation button. There you go. You're ready to go.
Yes. So effectively, you're in the warehouse, working through 3 schedules to get the product into the warehouse in that storage unit, and then using the mobile equipment, the LGV, with the LGV agent running the LGV, moving that product in the storage unit over to the mobile equipment, and then you're moving it with the LGV, moving it into packaging. At a high level, same page so far?
Exactly. Yeah. LGV goes, picks up this, it gets a storage tank that's been assigned. That was part of the request. Material gets moved into the storage tote. LGV moves over here, unloads it into the storage unit. That's part of the packaging storage zone. So, yep, exactly.
Great. And then we're taking from there, we are then defining you've defined the schemas, the data for all of the events and the telemetry data, switching back over to the other screen, then getting into that whole process. There you go. On the right side of the middle diagram, you've got the equipment hierarchy, enterprise site, area, work center, work unit, and defining each of the areas where information is going to go. On the left side is the sequence of the events. The green is the warehouse management system doing the work with the events with the work centers. The white buttons are the payloads for the LGV, the process telemetry data, et cetera. And then the orange are the movements of the materials from storage, from one place to another, from one work center to another. Exactly. And then you're essentially in that, behind those buttons, generating the data just for illustration purposes. And then you're showing that data all of that data in the MQTT Explorer, how all that works.
Correct.
Right. Okay, good. And then from there, we moved on to looking at the schemas, the data, and discussing standards, why they're valuable, and all the rest of that. Payloads, channel topics, schema for validation, data for validation, etc. That's a lot.
Yeah. There's a lot here for a very simple application, but
yes.
But once you've done it once, then it becomes very easy, and now you can move on and do a lot of things because of just problem. Can you make it scalable, extendable? That's what we're doing, and this approach does both.
And I think a couple key pieces that are missing links to make sure it kind of pulls it together. Well, how did we define all the events? Again, that's where the event storming comes in place. Where do we come up with the standards? ISA 95 is a great place to start. And also one thing, I don't know if you mentioned this or not, where did you get the schemas for MESA? You said you're going to define the website. What was that website?
Oh, yeah. So on this particular website, so this is a publicly available, you probably can't see that, but it's just json.libramfg.ai. And there's different versions. So if you just go right to the this post, and I can drop it into the video chat itself, so you can go to it.
Yep.
So what this is that the MESA, and I apologize, I don't remember. I've heard it said different ways. They did one in XML. There is a Git repository where you can download all this information. What this particular website is, instead of having one big massive JSON file, it's been broken up into these actual schemas itself, so that when you do your schema validation, you don't have to validate against all 50,000 rows within that large JSON. These are smaller, more digestible, more performant, and that's why I use this particular one. There is also a Git repository where you can download this entire project, you can pull it, and you can implement it into your own system as well. So if you don't want to validate against a public site, you can do that as well. So I'll provide some information or some links to both of those in the video as well.
Awesome. I just made a note to make sure that we do that. Great. That is everything. I think that was a really, really good session. A little long, but incredibly thorough and really important for this kind of process.
There's absolutely a lot going on, and it seems like, boy, that sure is challenging. I might be able to do it faster. And again, yes, you sure can, but can you make it scalable? Can you make it extendable? And this is how we approach it. What we found works the best.
All right. Anything else before my last and most important question?
No, I think I'm good.
What is the last LP you played on your turntable back there?
Oh, what do I have sitting out?
Any AC/DC going on?
Yeah,
or?
no, I hope it's something cool. Yeah, I don't. What did I play last on it? Because I have several things over here. I honestly, hang on a second. Now we're kind of derailing from it. But I went. Oh, yeah, I remember. I think I talked about this here recently. So yeah, Psychedelic Furs, Mirror Moves. This is actually circa 1980. Now I remember what it was. So yeah, that's what I played last here. And of course, I have a whole other system upstairs. And I think I was listening to the Emperor Concerto. I also published or posted about that as well.
Awesome. Good stuff. Good answer. All right. That'll do it. Thank you all. Like, subscribe, and we'll be back.
All right. Sounds good.